Welcome back to the second video for TEC 293 on Thursday, March 25th. In this video, we're going to talk through the first half of Lab 7. Lab 7 kind of has two halves. The first half is all about heat treatment, where we're going to take a bunch of specimens and we're going to apply different kinds of heat treatment to those specimens. And we're going to use the furnaces that are down in the plastics lab, which is the room right next to the Instron machine. We're going to talk through that in just a minute. The second half of Lab 7 is all about the impact testing. So we'll measure the amount of energy it takes for them to break. So we're not going to talk through that part today. I think we'll just save that part for a video next week. So next Tuesday, there will be a couple of videos. There's going to be a video on the heat treatment portion of Lab 7, where I'm going to do the heat treatment. You follow along in the lab manual. There will also be a video about impact testing, because that's where we left off in the slides today. And then on Tuesday, we'll also talk through the second half of Lab 7. So you can expect all of those things in the videos. None of them are really that long, but we'll talk through each of those things in the videos next Tuesday. Then next Thursday, like I mentioned in the first video today, that's when you'll come in person to do the impact testing portion of Lab 7. That's the second half of Lab 7. Once again, that's in Turner room 169. We haven't been in that room yet in this class, but it's the Woods lab. If you've ever been in the wood shop where they have the bandsaw, the circular saw, all of the sanding equipment and stuff like that, it's on the northeast quadrant of Turner Hall. Room 169, you'll find it. All right, so let's go ahead and talk through the first half of Lab 7. I recommend at this point you pull out your lab manual and you follow along. We're going to start on page 75. So let's get started, and I'm going to switch over to the document camera. To do this lab, we're going to need two furnaces. One's going to be at a higher temperature above the upper critical temperature for this steel, and one's going to be below the lower critical temperature. So we're going to have a high temperature furnace and a low temperature furnace. They take a couple of hours to heat up to these really high temperatures. This is not like cooking a pizza at 350 or 400 degrees Fahrenheit. These are going to be a lot hotter than that. So it takes a little while to let these warm up. So because they're so hot, we're going to need some tongs and some hot mitts and then some cooling stones, which are kind of like pumice, you know, like a really porous rock, and they don't conduct the heat onto the countertop, which could melt. And we're also going to need a bucket of water for quenching. This is probably my favorite part. I love taking the red hot steel specimens out of the furnace and then dunking them in the bucket of cold water. It's pretty fun. It makes a really, really awesome hissing sound. This is for the second part of Lab 7. We're going to need the Sharpie V-notch test machine. And of course, we're going to need our specimens. Here's what our specimens look like. And you'll notice that they have a notch in them right there. And that is to introduce a defect. This is a stress concentrator, or a defect. And by doing that, we are encouraging the part to fail right there. So we know where it's going to fail. All right, when we test this, we're going to put this into the holder in the impact testing machine, and then there's going to be a pendulum that swings down and hits it from the back right there, hits it from the back, and then it's going to cause it to fail. And the testing machine is cleverly designed so that we can determine how much energy the part absorbed as it failed. All right. So I got 6 of these. Each group is going to have 6 of these. So I'm going to do a total of 30 of these in the heat treatment processes. And we're going to do a different heat treatment process to each of the 6 that each group is going to do. So each group is going to have all 6 of these. Specimen 1, we're going to number these. Specimen 1 is going to be hardened with a water quench. Specimen 2 is first going to be hardened and water quenched, and then we're going to temper it. Remember what we said that tempering is going to do to the specimen. Specimen 3, we're going to harden and then water quench it. And then we're going to anneal it. Remember what annealing does to a specimen. Specimen 4 is going to be hardened, but not water quenched, so it's not going to cool down as rapidly as specimen 1. It's going to be air quenched, so it's going to cool down fairly rapidly, but not as rapidly as specimen 1. Specimen 5 is just going to be like this. It's just going to be as given to you, kind of as we got it from the metals distributor. And specimen 6 is probably the most fun one, because we're going to take it just like this and we're going to dunk it in liquid nitrogen. In fact, we're going to let it soak in the liquid nitrogen for at least a few minutes to get it really good and cold. It's going to be really, really cold, well below what the ductile to brittle transition temperature is for this 1045 steel. All right, then the procedure here for the first part of Lab 7, we're going to have one furnace at 1,550 degrees Fahrenheit. That is, it's hard to describe how hot that is. Students, when they do this in person in previous semesters, when they open up the furnace for the first time, they're always kind of shocked at how much heat there is right there. This is way, way hotter than cooking a pizza at 350 or 400 Fahrenheit. And the purpose of this furnace is to get the specimens, the materials, above the upper critical temperature. Then we've got the other furnace that we're going to heat to 1,100 degrees Fahrenheit, still really, really hot, but this is actually below the lower critical temperature. All right, what we're going to do in step 3, what I'm going to do so that you can identify which one is specimen 1, which is 2, 3, and 4, what I'm going to do is I'm going to make a notch on the other side from this notch. So here's the main notch that's important for the testing purposes. So I'm going to make a notch over here. One notch will mean specimen 1, 2 notches will mean specimen 2, and so on and so forth. Up until specimen 6. Specimen 6 is going to have no notches. All right, so if you see a specimen with no notches, you know what, actually what I'm going to do is specimen 5 and 6 are going to have no notches. That way I don't have to make as many notches. So specimen 1 will have 1 notch, specimen 2 will have 2 notches, 3 and 4 notches respectively. And then 5 and 6 we'll be able to identify. 5 is going to be the one that I give to you, and it's going to look like this. It's just at room temperature. And then 6 is going to look the same, but we're going to put it in liquid nitrogen. So we'll be able to tell which one's specimen 6 because it's the one that's in liquid nitrogen. Otherwise, 5 and 6 they're going to look the same. That's fine. They'll look the same, but 1 we'll put in liquid nitrogen. All right, so that's what I'm going to do to minimize the number of notches I have to put in these things. And then what we're going to do for specimens 1, 2, 3, and 4, 1, 2, 3, and 4, for these 4, we're going to put them in the high temperature furnace for at least 30 minutes. We got to let them soak in there to get them hot all the way through. So we want the whole specimen, even in the middle, to be at 1550 degrees Fahrenheit. After 30 minutes, we're going to take specimens 1, 2, and 3 from the high temperature furnace, and we're going to put them in the bucket of water. We need to do this pretty quickly. You know, we don't want to poke around. Within a couple of seconds of them coming out of the high temperature furnace, we want to dunk them in the water, the bucket of water. And this is going to not let it cool down very much before we force it to cool down rapidly by putting it in that bucket of water. And that's called water quenching. We're quenching it with water. And remember, specimens 1, 2, and 3 were all water quenched. So that's why we're doing this with specimens 1, 2, and 3. This is my favorite step. This is my favorite part because it lets out that big hiss when you dunk this. I mean, it's gonna be red hot, like cherry red, coming out of that furnace. And we're gonna dunk it into the water, and it's gonna make a pretty fun noise. This is pretty fun. Specimen 4, remember specimen 4 is going to be hardened, but then air quenched. All right, so we're not going to dunk it in the water. So specimen 4, we're just going to take it out of the high temperature furnace and then put it on the cooling brick. And we don't want to put it on the countertop because it will melt that Formica mounted countertop. All right, this is air quenching, and then it's going to take a little while to cool down. I'm just going to set it there and leave it there until the next class period when you all come in to do the second part of Lab 7. Okay, then we want to leave those water quench specimens in the water for a couple of minutes just to let them thoroughly cool down before I handle them. I don't want to be touching the specimens that are still extremely hot. I don't want to burn myself. So we'll let them cool down for a minute or two in the water. And then we're going to take specimen 2 from that had been water quenched. And remember, specimen 2 is going to be tempered. Remember what the tempering process involves. We're going to put this in the low temperature furnace. So this is going to be just below the lower critical temperature for at least 30 minutes. Specimen 3, what are we going to do with specimen 3? It's going to be annealed. All right, so remember what the annealing process entails. We're going to take and put it back into the high temperature furnace and leave it there for at least 30 minutes. So at this point, we've got specimen 1. We can take it out of the water, so it's cooling. It's cooled down. It's been cooling down in the water, so it's cooled down. Specimen 4 is still hot, but it's being air cooled. And specimen 5 and 6, remember, we're not doing anything with that. We're not doing anything in this procedure with specimen 5 and 6. And 2 is in the high temperature furnace, and 3 is in the low temperature furnace. Okay, then after we wait 30 minutes, so specimen 2 is cooked all the way through. It's all the way, even in the middle of the specimen, it's back up to the, it's up to the low temperature, 1100 Fahrenheit, and specimen 3 is back up to its temperature of 1550 degrees Fahrenheit all the way through the specimen. Now, specimen 2, remember that's being tempered. We are going to take it out of the low temperature furnace, and we're going to put it on a cooling brick, and then we're going to wait. We're going to wait actually till you guys come in to pick up the specimens. We're going to wait for it to cool down. So this is tempering. When we brought it up to slightly below the lower critical temperature, and then we're going to cool it down in air. It's going to be cooled down at room temperature air. Specimen 3 is going to be annealed, and remember, to anneal something, we want to heat it up above the upper critical temperature, but the really critical thing about annealing is you let it cool down really, really slowly. So what we're going to do, even after that 30 minutes is up, we're going to leave specimen 3 inside that high temperature furnace, and we're just going to turn off the furnace. That's all we're going to do. We're going to turn off the furnace, and we're not going to open the door to the furnace. We're just going to let it cool down gradually as the furnace itself gradually cools down over the next 24 hours or so. And that's annealing. All right, so by the next day, and certainly by the time that you all come in to do the second half of Lab 7, all the samples will be cooled down. You might actually see some of the specimens, especially say specimen 1 and specimen 4, or really possibly any of these that have been hardened. You will possibly see some kind of black flakes around the outside of the specimen. We call that scale, and that's carbon. That's actually carbon that has left the inside of the material. It's pretty cool and pretty weird to imagine that right now there's carbon inside here, and we're going to change the form of that carbon by doing this lab. And in fact, some of that carbon is going to kind of scale off. It's going to form some carbon scales on the outside, and it'll just kind of flake off as you pick it up and handle it. All right, so that's the end of the first half of Lab 7. So I'll make a video about that. As I do that for the next class session. And then I'll get the specimens and I'll bring them down to the Woods Lab, Turner 169, which is where we're going to meet to do the second half of Lab 7. All right, so I really enjoyed this lab. I hope you enjoy it too. I think this is pretty fun. The heat treatment part is pretty fun, and the impact testing is fun, and working with liquid nitrogen, it's always kind of fun. It's an unusual kind of weird substance that is extremely cold, so it's kind of fun to play around with. Once again, remember, if you want to bring in something like a piece of fruit or marshmallows or a flower or something, you can bring that in, and we can kind of put that into the liquid nitrogen after all the groups have done their testing on the second half of Lab 7. So that's going to wrap things up for today. In the next class session, I'll make a video doing the heat treatment processes for the specimens, and we will talk about how to do the second half of Lab 7. So I'll see you next time.